Alright, so in this equation, I have 3 to the power of x to the power of 3 over 9 to the power of x is equal to 81. So, to solve this, I'm going to first write 9 as 3 squared. So I get 3 to the power of x to the power of 3 over 3 squared to the power of x is equal to 81. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of x to the power of 3 over 3 to the power of 2 times x, so 3 to the power of 2x, is equal to 81. I'm going to rewrite as 3 to the power of 4. So now notice how I have everything in the base of 3. So this is going to make it much easier to solve. Now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So 3 to the power of x to the power of 3 over 3 to the power of 2x is going to equal 3 to the power of x to the power of 3 minus 2x, which is equal to 3 to the power of 4. And now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So x to the power of 3 minus 2x is equal to 4. And now if I subtract 4 on both sides, I get x to the power of 3 minus 2x minus 4 is equal to 0. Now we have an equation here, and this isn't a regular quadratic equation because we have a power of 3 here, and we have a missing power of 2. We don't have the power of 2. So to actually solve an equation like this, what we have to do is we have to test out values, and then once we get a value that works out, we have to use that one value to find all the remaining values that are solutions to the equation. So let's first start out with 1. If x is equal to 1, then I get 1 to the power of 3 minus 2 times 1 minus 4, which does not equal 0. Now if x equals 2, I get 2 to the power of 3 minus 2 times 2 minus 4. 2 to the power of 3 is 8. 8 minus 2 times 2 is 4, and 4 minus 4 is 0. So this does equal 0. So 2 is a solution. To be more precise, x equals 2 is a solution, meaning x minus 2 is equal to 0. So now what we're going to do is we're going to divide x minus 2 with x to the power of 3 minus 2x minus 4. So I get x to the power of 3 minus 2x minus 4 over x minus 2. And to solve this, we're going to have to use synthetic division, and if you guys don't know what that is, I would recommend watching a YouTube video on it. So our coefficients of our numerator is 1, -2, and -4, and then we have a 2 over here. I'm going to bring down 1. 2 times 1 is 2. -2 plus 2 is 0. 2 times 0 sorry, I actually did something wrong. We should have a 0 in here because, remember, we have a power of 2. So because there's no power of 2 here, we just put a 0. Now, if we bring down 1, we get 2 times 1, which is 2. 0 plus 2 is 2. 2 times 2 is 4. -2 plus 4 is 2. And 2 times 2 is 4. -4 plus 4 is 0. So we have a remainder of 0, and we get x squared. Our coefficient is 1 plus 2x, coefficient is 2, plus 2 at the end. So I get x squared plus 2x plus 2 is equal to this. And this also means that x minus 2 times x squared plus 2x plus 2 is equal to 0. So for this equation, I get x minus 2 is equal to 0, and x squared plus 2x plus 2 is equal to 0. For x minus 2 equals 0, x is obviously equal to 2, and we already got this solution before, so this is no surprise. Now for x squared plus 2x plus 2 equals 0, to solve this, we have to use the quadratic formula, which is -b plus or minus the square root of b squared minus 4ac all over 2a. So I get x is equal to negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times a, which is 1, times c, which is 2, all over 2a, so 2 times 1. And now this is equal to negative 2 plus or minus the square root of 4 minus a, which is negative 4, over 2, which is equal to negative 2 plus or minus the square root of 4 times negative 1 over 2, which is equal to negative 2 plus or minus 2i. Square root of negative 1 is the same thing as I, over 2, which is the same thing as negative 1 plus or minus I. So my three solutions to the equation are x equals 2, x is equal to negative 1 plus I, and x is equal to negative 1 minus I. Alright, so in this problem I have m minus n squared is equal to m squared minus n squared. So to solve this problem, I'm going to first start by rewriting m minus n squared. And I'm going to rewrite this to m minus n times m minus n. Now from here, I'm going to expand this by multiplying these two. So to multiply these two, I'm going to first start by distributing the m. M times m is m squared. M times negative n is negative mn. Now I'm going to distribute the negative n. Negative n times m is negative mn. And negative n times negative n is positive n squared. So I have this is equal to m squared minus n squared. Now, I can do a few things here. I can first start by subtracting m squared on both sides, so this way these two m squares cancel out. And now I'll be left with negative mn minus mn plus n squared is equal to negative n squared. Now negative mn minus negative mn is equal to negative 2mn. And then now if I subtract n squared on both sides, these two cancel out and I get negative 2n squared. Now from here, I can divide both sides by negative 2. So then these two negative 2's cancel out, these two negative 2's cancel out, and I'm simply left with mn is equal to n squared. Now from here, I'm going to subtract mn on both sides. So then these two cancel out, and I get n squared minus mn is equal to 0. Now the greatest common factor in n squared minus mn is n. So if I factor out n, I get n times n minus m is equal to 0. So now this gives me two equations. I get n is equal to 0, which is already a solution, and I also get n minus m is equal to 0. Now, going back to our original equation, we have m minus n squared is equal to m squared minus n squared. If n equals 0, I get m minus 0 squared is equal to m squared minus 0 squared, which turns into m squared is equal to m squared, meaning m can really equal any number. If m equals 5, then I have 5 squared is equal to 5 squared. If m equals 100, I get 100 squared is equal to 100 squared. So m can equal any number if n is 0. Now for here, I have n minus m equals 0. So if I add m on both sides, I get n is equal to m. Now, if I put this back into my regular equation, I have m minus n squared is equal to m squared minus n squared, and I'm gonna rewrite n as m because they're both equal to each other. So now I have m minus m squared is equal to m squared minus m squared. M minus m is 0, so I have 0 is equal to 0. And this means that they're both equal to 0. So now going back, what I'm going to do is do a different method to solve this problem. So method 2 is, first let's rewrite the equation. We have m minus n squared is equal to m squared minus n squared. And now this time, I'm going to again expand m minus n squared to m minus n times m minus n. And now from here, I'm going to rewrite m squared minus n squared as m plus n times m minus n. Because if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So now, as you see, we can simply divide both sides by m minus n, cancel these two out. So now I'll be left with m minus n is equal to m plus n. Meaning, if I subtract m on both sides, I get negative n is equal to positive n. If I add n on both sides, I get 2n is equal to 0, meaning n is also equal to 0. And if n equals 0, then remember how we already tried this out, m is also equal to 0. So these are my two solutions to this equation.